Last week we looked at transforms. We looked at the three primary transforms, which are translation, scale, and rotation. And what we've learnt is we've learnt how to do vector addition, which is in the translation. So you can see that mathematically vector addition will look like this. P dash equals P plus V, and these are all vectors. So P is the original vector, P dash is the transformed vector, and V is the translation vector, which is basically how much we're going to move. And again, we did this in code, and we did it by going rv.x, which was our return vector, is p.x, which was the input position or point, and we added v.x, which was the vector we were displacing. So we understand what it looks like mathematically, and we understand what it looks like in code. We did scaling as well, and scaling is called vector scalar multiplication. In mathematics it looks like this. So you have p dash is equal to p times s, where p dash and p are both vectors and s is a scalar. So again, if you think about the difference between a vector and a scalar, a vector is a complex number. It has multiple components, and a scalar only has one component. So we achieve this in code by taking rv.x is equal to p.x, the point, multiplied by s, the scalar. We did the same thing with the y. So in this will enable us to do scalar multiplication. Then we also did rotation. And rotation was a combination of vector addition and multiplication. And you can see the components are, we have a scalar multiplication of a vector subtracted from another scalar multiplication of a vector. And then with y, we have a scalar multiplication of a vector plus a scalar multiplication of a vector. So we know intrinsically how these things actually work. We also learned that the order of operations is important, that we have scale, rotation, and position, and it's very important that we get them in the right order because of the way that the rotation and the scale transform work. In other words, they will work from the origin, and if you apply a position to a vector, you will offset it from the origin, and therefore the rotation and scale won't happen about the expected center point. So before we examine 3D graphics, we need to look at how matrices can be used to take all of these calculations, so these three calculations, which are very common in computer graphics, and combine them into a single matrix. And then we just multiply the vector by the matrix, and it will do all three transformations in a single go. So that's the power of using matrices. And so I want you to have a look at matrices and do your best to see if you can understand the complexity behind them. Okay, so you can apply this transform to the given shape. You could then take that shape and you could change it so that it was your initials, and then hopefully you were able to take that same code as you understand it and apply it to the asteroids code. So if we have a quick look at where the asteroids should be, so we should be at this point where we can rotate the ship around. We should be able to fire, we should be able to do collision detection. We should have the asteroids bouncing off the edges. And that's where I wanted you to be for last week. For this week, we're going to add thrust. So if I press the up arrow, you can see that the ship moves. And what happens is that it will move, it will accelerate because we apply an initial force. And then it will gradually slow down again because there is friction or air resistance applied. We don't normally consider air resistance in space, but it does make the game a lot more playable. Without it, the ship would just keep moving. So let's have a look at where we are. I also wanted you to look at some questions on the examples. I want you to go through this. I think the sticking point was mainly to do with the firework. Hopefully you can see that the firework is just a simple question. Can you generate a point inside a circle? So previously you've been testing to see if points were inside a circle, but this is slightly different. We can't just randomize a point and see if it's in a circle. We actually have to generate a point inside a circle. And in order to solve that problem, you have to go back to the rotation equations.